Hi everyone, this is John Wen. Today is November 25th, 2020. Tomorrow is a Thanksgiving. I hope all of you guys will have a great Thanksgiving day. And here is updates since the past week on my research item. And I was focused on the deep learning workflow, the single item. And I think I made some progress since the past week. So here is a review that I was working on a streamlined simple CUDA neural network in a workflow. Basically, we're trying to call that CUDA from the workflow tasks. Basically, that's from the GenAI. And we are trying to simplify the user input, and user only need to input the layers they want. For example, like they want a linear layer, relu layer, linear layer, and sigmoid layer. So this is a simple example. And here is updates. I've done 2 tests since the past week, and more will be ongoing. And first one is I try to compile the whole CUDA project into a single DLL, and I was able to do that. And also, I try to call a single method in the Java to call this to have this neural network to run, which is successful and done. So basically, if you take a look at firstly, maybe we can take a look at the CUDA code. And here is a test one. And basically, I'm writing a main test.cu, and which is going to have a method which is called the main test. And this is going to have all the construction of the neural network preset, as well as calling the train and testing method. So basically, I compile all the relative CUDA code into a single DLL, and successfully I was able to run that in the Eclipse. So as you can see here, CUDA main.java, and I was able to call this main test.dll from the GenAI test folder, and then I was able to call the CUDA main. So if we run this, and we'll be able to see that. Let me try it again. Oh, sorry, I think I do the wrong file, and should be this one, main test.java. So if we run this, we'll see that the CUDA code is going to run. And if we check the service, and we will see the GPU is going to be occupied, which has 74% utilization right now. So if we took a look, you can see a peak just happens since right now. We are using the CUDA code from the GenAI. Basically, it's running the epochs, first epochs and second and so on. It will continue until 1000. I think that's the preset. So this is the first item I was doing from the past week. And the second one, I try to refine a little bit and try to dynamically feed the input as a hash map to specify the layers with specifications. So what does that says? What does that mean is I want to have some input to dynamically construct the new network and then let it run. So basically that's a further step we want to towards the purpose. We want the user only to specify the layers, and the neural network will be able to run. So this has been separated into 2 parts. In the Visual Studio, it's successfully and done. Basically, I was able to dynamically feed a hash map dynamically to construct a neural network and to let it run. So if we take a look at the Visual Studio, so if you take a look at the main.cu CUDA code, basically I'm trying to feed a hash map into the main method, and here is a rule. Basically, we will have a hash map, and the first basically will have a integer as well as a integer array. So if you take a look at here, so we are taking the hash map, which is key is an integer. that specify the number, the index of a layer, and then we have an integer array which contains a specification of that layer. So let's take a look at the example. So here, for the first integer which specify which layer we are going to use, we are going to have the number of the layer, the index of layer in the first integer, and here is a code to parse the different layers. Basically, we will look through all the layers, and then we will check out their specification and to initialize a layer instance. So here is an example for the second part, which is array, and the first integer in the array will specify what kind of layer we want. Here we have three kind of layer. If we specify 0, that means we are going to have a linear layer, and then we will have to input the second and third parameter in that array. The second parameter will specify how many input neuron we want, and the second one will specify how many output neuron we need. So basically here you can see 0 to 30, that means we are going to have a linear layer, and we are going to have 2 neurons as input, and then we have 30 neurons as output. And here we have the second array. The first element in the array is 1, that means we are going to have a ReLU layer, and the same thing applies to the rest of layers. So if we are running this code, running this main method, and we will be able to see that the linear layer has been added to the neural net, and ReLU layer has been added to the neural net. Similarly, linear layer 2 has been added to the neural net, and sigmoid layer has been added to the neural net, and then we will know that the neural net has complete construction, and it will start to training for 1000 epochs. So you can see here, similarly, we have the epoch 0, and you can see from here it's running. If we take a look at the service again, we will be able to see that it's running. The GPU is in a high peak as well. So this is work have been done in the Eclipse. Let's close this one. But the problem is that if we take a look at the code when we want to use a GNI, and here is a problem. So basically, I think I need to open this one. So this is a second test. Basically, this is a CUDA file. I use multiple editors, and because it's really convoluted sometimes. So the problem is here. If we want to use a GNI, and here is a method that is generated from the header file. So we only get the J object that's input into the CUDA file. So what we need to do is we need to parse this J object into a map, or into a hash map that's already been written in the Visual Studio or the CUDA code that is acceptable. But right now we need to have this bridge to parse the J object into this kind of real hash map in the C++. So I've done some research, and I also put some code try to make this happen. Basically, this is a method to convert the Java hash map to the CUDA hash map. I'm trying to, because this is a little bit complex, we have to parse a lot of Java method or class, and then we are going to loop through the object, and we are going to get the keys and the value, and then we will do the simple. We will basically create a new map in the C++, but right now it's not working yet. But I think I will try to make this happen. Otherwise, maybe we need to think about to use a simple format to transfer the data. Maybe just an integer and an integer array. No need to have a map instead. So that's a challenge, as well as that's ongoing work will be done in coming week. So hopefully we will have a full utilized version soon, because I'm really looking forward that we can have something as an input maybe here. For example, like in the main test to.java, here is a complete version. If we have the DLL ready, and basically we will have a hash map constructed, and then we will parse this hash map into the simple neural network method, which is going to call from the native, which is going to have the GNI to link to the CUDA code. So this is something I'm going to do, and hopefully this can be done soon. And then I will think about how to convert this kind of simple Java code into a workflow, basically into a tasks and concatenate with each other. So that's the update for the past week. Hope you enjoyed the video, and thank you so much for your time. Until next time, happy coding and happy Thanksgiving.